Hello everyone. In today's video, we will know about ISTIO. What is ISTIO? Why we need ISTIO? What are the features and benefits? So let's go to agenda. So in this video, we will learn about what is ISTIO, why we need ISTIO, features of ISTIO, what is service discovery, key concepts of service discovery, and example scenario. And what is sidecar proxy and why, what is canary deployment and example scenario in ISTIO. So first we will know about what is ISTIO. ISTIO is a open source service mesh that provides a way to control and secure communication between the microservices. And ISTIO is a service mesh that layers on top of Kubernetes to handle the network communication between your services. And also it enhances the security, observability, reliability by managing how data flows between microservices. And also ISTIO helps addresses these challenges by providing a layer of infrastructure between the microservices and the network, which allows for centralized management of service to service communication. Why we need ISTIO? ISTIO is used primarily to manage, secure and monitor the communication between microservices and distributed applications. Why we need means it enhances the security, traffic management, observability, resilience and decoupling. So let's know one by one what is enhanced security. It provides out of the box security feature including mutual TLS. So mutual TLS we are also called as MTLS for encrypting the communication between services, authentication and authorization. And traffic management. ISTIO allows fine-grained control over how traffic flows between the services. In traffic management, it shows how the traffic flows between the services, and also it includes routing, load balancing and policy enforcement. The next is observability. ISTIO enhances the observability by providing matrices, logging and tracing capabilities. This helps in monitoring the service performance and diagnosing the issues. The next is resilience. In the resilience, ISTIO helps build resilient service by implementing the retries, timeouts and circuit breaks, which can be configured easily. In the resilience, we can easily configuring and implementing the retries, timeouts and circuit breakers. The last one is decoupling. In the decoupling, it abstracts the communication layer, allowing developers to focus on the application logic without worrying about service to service communication details. So these are all the why we need ISTIO. The next is feature of ISTIO. ISTIO offers a wide array of features that help manage, secure and observe. So microservices in service mesh here are the key feature of ISTIO. Traffic management. In traffic, I've already told that traffic management contains load balancing, traffic splitting, retries and failovers, traffic mirroring, authentication and authorization. The next is security. In the security, it contains mutual TLS, authentication and authorization, end-to-end encryption. In observability, it contains matrices, distributed tracing, logging, and the next one is policy enforcement. It contains resource limits, access control, rate limiting, quota management. The next is service discovery, automatic registration, dynamic routing, consistent naming. So traffic management. ISTIO provides a fine-grained control over the flow in traffic in a microservice environment. It allows you to define routing rules and policies for how traffic is directed between services. You can control traffic flows using some features like load balancing, traffic splitting, retires and failovers, traffic mirroring, like that. The next is security. ISTIO offers several robust security features that help secure communication between microservices and protects sensitive data. Mutual TLS is a security protocol that ensures both the client and service authentication each other using certificates during the communication process. The next is key benefits like authentication, encryption, automatic key management. The next is observability. Observability is critical in understanding the behavior of your microservices, tracking performance, and debugging issues. Istio provides powerful tools for matrices, distributed tracing, and logging. In the matrices, Istio integrates with a system like Prometheus and to collect and visualize the matrices to service in the mesh and distributed tracing. Istio integrates with tracing systems like Jagger and Zipkin to enable the distributed tracings. So it's a trace request flow and latency analysis are the key benefits. And the next is policy enforcement. Istio provides administration with the ability to define and enforce rules for managing the services in a microservices enforcement. These policies help maintain service reliability, control access, and prevent abuse of overuse of the resources. The next is service discovery. Service discovery automates the process of identifying services within a microservice architecture. It ensures that service can dynamically locate and communicate with one another without needing hard-coded address or manual configuration, like automation registration, dynamic routing, consistent naming. The next is what is service discovery? Service discovery is the automated detection of service available on a network. In microservice architecture, new services are constantly being added or removed, and service discovery ensures that the other services can find and communicate with these services without manual configuration. The next is key concepts of service discovery. The main key concepts are dynamic registration, service registry, client-side discovery, server-side discovery, and health checks. So let's know one by one. What is dynamic registration? So when a service instance starts, it registers itself with a service registry, providing information such as its network location like IP address or port number and metadata. When a service instance shuts down, it deregisters itself. So when we already give the information, so it's in case it instance shutdowns, it deregisters itself. The next is service registry, a centralized database or system that keeps track of all service instances. It allows other services to query for the available instance of services and their current locations. The common service registries include Console, Eureka, and etcd. The client-side discovery. In this model, the client, means the service needs to call another service, is responsible for querying the service registry to find available instance. The client then makes request directly to the chosen service instance. This approach requires the client to have knowledge of the service registry. The next is service-side discovery. In this approach, the client sends request to a load balancer or proxy that is responsible for querying the services registry and routing requests to appropriate service instance. This abstracts the discovery logic away from a client. The next is health checks. Service registries often perform health checks to ensure that only healthy services instances are available for discovery. If an instance fails a healthy check, it removed from the registry. So it provides only healthy services. In case any instance or failed like that, it removed from the registry. The next is example scenario. So imagine you have one payment services and any shipping services. So when the payment services finishes the processing, it need to notify. I think you can pay any online payment. You get the notification like your payment is successful, otherwise failed to payment in the network issue, like that. So service discovery allows the payment service to automatically locate the shipping services endpoint. Even if the shipping services is on different instance or server, we can it's in different instance or different server, it's automatically locate the endpoint service. The next is canary deployment. First, we know what is canary deployment. The canary deployment is a technique used in DevOps to releasing new software version incrementally. The name canary comes from the phrases canary in a coal mine, so which refers to the practice of using canaries to detect hazardous conditions. The goal is to test the canary deployment. Main goal is to test the new functionality on a subset of customers. So before releasing any functions, first it need to test and then to release the customing to entire user base. So you can choose randomly or a specific group of user and roll back if anything breaks. If everything works and intent, you can gradually and more users while monitoring logs, errors and software health. So example scenario of canary deployment. It's like imagine if you have a fictional any online applications like you think e-commerce or online banking application. So in the banking application, it's updating its transaction processing features. In the e-commerce, it's deploying all the users and release it 5% of users, and they monitor the performance and user feedback. In the e-commerce app, you can buy anything, or then it take the users feedback in the in one application like Myntra or Flipkart, you can buy any item. So then you give feedback, its product is satisfied you or not, its quality, quantity, like this monitor performance and user feedback before rolling it out to the rest of the users. So before releasing to everyone, it needs check, and based on the feedback it can be releasing. So first what are doing, first it's a initial deployment, later canary release, and then monitoring the key performance such as transactions, like that. The next is evaluation the version performance, and the next one is rollback, means if any major issues are detected, it can quickly roll back the changes and ensuring that only a small number of users are affordable. The next is Envoy sidecar proxy. Sidecar proxy is a key component of service mesh architecture like ISTIO. It's a smaller helper process that run alongside each microservices, intercepting and managing its network traffic. In ISTIO, the sidecar proxy is typically an instance of Envoy, which is responsible for controlling and securing the communication between services. The next is Envoy. Envoy is an open source edge and service proxy designed for cloud native application. It was developed by Lyft and is a key component of service mesh architectures like Istio. Envoy acts as a sidecar proxy, providing a range of features to manage the communication between microservices. The example scenario of sidecar proxy. Like imagine an e-commerce application with multiple microservices like product, cart, order. So first you like something, you can add to the cart, then you order, like this. So deployed in the Kubernetes using Istio as the service mesh. Each microservice as an Envoy sidecar proxy. When a user interact with the cart service, the request is first received by Envoy proxy. So Envoy performs the security checks, routes the request to application services, and collect the matrices. So first you wash the one product and you can add to this cart, then you need to order. Before ordering, when we putting in the card, the envoy performs the security checks. Later we need to order. So the response from product service is also routed through envoy, which can log the responses time and the error rate. The next is example scenario in ISTIO. So you have a catalog service in your e-commerce platform which communicate with other service like order and payment. So you need to catalog service for one. So first you need to communicate how much order you want and the payment goes on. The later envoy is deployed as a sidecar proxy for the catalog service. When catalog service makes request to the order service, the request first go through the envoy sidecar. Later it ensures that traffic rules such as retry policies or circuit breaking are applied. Then the traffic between services is also encrypted using mutual TLS. It providing security without needing to change the application's code. So without change anything, it provides the mutual TLS providing security to the application. Then we can easily provide the services. So this is all about ISTIO, why we need, what are the importance, what is service discovery, and key benefits and features, example scenario. This is all about the ISTIO. Thank you.